Section 1.1 notes, order of operations. Up at the top, you have your objectives. So these are the things that you should be able to master. I can solve advanced numerical expressions using order of operations with multiple grouping symbols. I can use a graphing calculator to solve expressions involving order of operations. I can evaluate powers. I can state the squares in their roots from 1 to 15. I can state the cubes in their roots from 1 to 10. Today we're going to focus on just the first page of the notes. Tomorrow we will do the back. A numerical expression is made up of numbers and operations. So a numerical expression is made up of numbers and operations. You have fractions, addition, subtraction, decimals, multiply, divide, and you have whole numbers. To work with order of operations, we have GEMS. You're used to using PEMDAS. Please excuse my dear Aunt Sally. GEMS is very, very similar to that. In order to correctly simplify numerical expressions, we will follow the order of operations. The G in GEMS, grouping symbols. Any of these you would evaluate first. Parentheses, brackets, braces, absolute value, radicals, fractions. E, exponents, examples. M, multiply and divide. This is important. You always want to do this left to right. Subtract and add, very important, from left to right. So GEMS are your grouping symbols. E, exponents. M, multiply and divide from left to right. S, subtract and add from left to right. Absolute value. Let's review it just a minute. Absolute value, this is the definition. It is the distance a number is from zero. The distance a number is from zero. This is the symbol for absolute value. So two examples. The absolute value of -3. The distance a number is from zero. So here's -3. Let's find its distance from 0. 1, 2, 3. So the absolute value of -3 is +3. The absolute value of +4. By the definition, it's the distance a number is from 0. So here's +4. Let's go to 0. 1, 2, 3, 4. So the absolute value of 4 is 4. Let's look at powers. Start with a definition. A power tells how many times the base is multiplied by itself. The b, the lowercase b here, is the base. N is the exponent. So a power tells how many times the base is multiplied by itself. So whatever this number, we will multiply this number that many times. So let's look at 6 examples. All right. Problems 1 and 2 deal with your square power. So power of 2 squared, or we could say to the second power. So 3 squared, the 2 means we'll write the base 3 2 times. 3 squared means 3 times 3, which is 9. 5 to the second power means we write 5 down 2 times. 5 squared, 5 times 5 is 25. For examples 3 and 4, when you have an exponent of 3, we would say cubed or third power. So 2 cubed means we write 2 down 3 times. 2 cubed is 8, or 2 times 2 is 4, times 2 is 8. 5 to the third power. 5 times 5 times 5. 5 cubed is 125, or you can evaluate 5 times 5 times 5 for 125. Exponent of 4, we would say to the fourth power. So examples 5 and 6, number 5. 2 times 2 times 2 times 2, 2 to the fourth. 2 to the fourth is 16, 2 times 2 is 4, times 2 is 8, times 2 is 16. Example 6, 3 to the fourth. You take the base and you write that base down 4 times. So 3 to the fourth is 81, or you could evaluate it. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So before we get into the actual order of operations, we need to make sure that you understand absolute value, that you understand powers and how they work. If you have any questions, make sure that you ask during this tomorrow during this next 30 minutes. You can email me. Just make sure if you have a question that you do ask.